Okay, so first video I'm putting together is for the bandsaw. It's going to be one of the projects that you will be using in the Millwright Power Tools performance eval. What you're going to do is you're going to cut a piece of plate 1/2 inch thick, 6 inches wide, and we're going to cut it 6 inches long. I'm not going to cut that piece in here. I'm just going to cut a little sliver off of here so you guys see how it's done. But that's what you will be doing in the performance eval. So, but before we do anything, I'm going to take you through and show you how this saw works, and then I'll show you in another video probably how to physically go through and start it up and cut it and stuff like that. The first step before we do anything with the saw, since we're going to be looking at the blade and doing different things, we're going to follow the electrical cord over to the gear switch to lock it out. Remember, always turn your head away, roll the switch down. Out in industry, we would put a lock on it. As you see on this other one, there's a lock on it so people can't use it. But since I'm going to be right here and I'm going to be turning it right back on again, we're not going to go through that. Going back over here to the saw now we have no power. The first thing we're going to check is to make sure the blade is straight. So I've already run it out there, so it's in the bed there, and now I can use a square to go up here. Most of the time when we start, this guard would be down lower. We're going to set it when we get ready to cut the plate so it has support there on the blade. But to check the blade, we would just loosen up this hand knob over on the side, and then we would lift or lower the blade. So you won't be able to see those rollers with the blade in there, but they're realistically right here, and that's what gives the blade support to keep it from deflecting. So when we're cutting things, we want it down here closer to the material to keep it from deflecting as we're cutting. The blade teeth are facing downward. It's going to spin in this direction. It's going to cut down through the metal. So back to the blade. We want to use the biggest square we possibly can to get an overall height or an overall look. Sometimes if you have to use something like this, you see the limitations of it. We're only going 6 or 8 inches out on the table. And if we go this way, we're only going a few 6 or 8 inches up on the blade. So we always want to use the biggest square we can because it covers the most area. We're going to slide it up to the blade, and then we would be looking against it to make sure it is at the table and at the proper. If it's 90 degrees here, we're cutting a square line or a square cut. So that's how we would do that. To change the angle, if you wanted to cut something at a bevel for cutting a groove or something like that, that we were going to weld pieces together, we would loosen this handle. And I'm not going to move it, but we'd loosen this handle, pull the machine over using this scale here. We can go all the way down to a 45-degree angle if we wanted to. And that head is going to rotate and move like that. So, but that's how we would do that. And like I say, the biggest square we can get in there is going to be the best way possible to do this. So when we get ready to cut, we're going to have the metal laying like this. So we're going to bring this guard back down as far as we can to give that support as much as possible. Now, 1/2 inch is pretty thick material. So we're going to have the piece in like this. A lot of times you're cutting 1/8 inch, 3/16, 1/4 inch. And a lot of people will set it up like that. We would still clear our guard, but probably lift it up just a little bit to have a little extra clearance. And we would slide that in and do something like that. But since it's 1/2 inch, it's easier on the saw to cut it this way. So here's our clamp. We always clamp something down before we cut it. It's as simple as it slides through there. We tap it, we pull it down. Now it doesn't move, the piece is clamped in there. I'm not going to do that yet because I'm going to have to put it through in different ways. Over here on this panel, usually this number is lit up here telling us what our blade speed is. Because I have the power shut off, it's not lit up. But here would be our run button, here would be our stop button. This head feed is going to work back and forth, and it's going to increase or decrease the speed of the blade coming here. This number on here is going to match this chart, and it's going to tell us, for example, we're going to be cutting carbon steel, and it recommends 150 feet per minute that the blade is moving. So over here is a pneumatic valve that controls. It's in the neutral position right now. This is, when we move it that way, it's going to move the blade this way, which would be this way, and then we would increase the speed. By turning this knob, and I don't know if you want to come over on the side, you can see the blade moving at that point. And then if we switch the handle back the other way, the blade would go back. I'm going to hold it about there, so when we go to mark the plate, it's in fairly close. So again, we will adjust the rate of speed with this knob here. So I think that is all the features. Oh, the blade is lubricated. You don't have to add oil or anything. There is a pneumatic application, then this tank holds oil, and it will be injected down here to the blade to help cool the blade. The blade cools as it runs all the way around there. And then we add an oil mist lubricant to cool the blade to keep it from wearing out. So with that said, we would go back over and we would roll the breaker box back in, and we'll be ready to, again, start the blade, stop the blade. So what I suggest to everybody is you run that blade up here as close as you can get it, and then we would bring this through. You guys are going to cut a 6-inch piece. So, kind of like with the abrasive cutoff saw, the easiest way is to put it up against the blade and say we were cutting a 4-inch piece. Make that measurement with the tape right to that. But, like I say, since I have a small piece here and I don't want to waste a bunch of it, we could go out here to 6 inches and make it there. The accuracy of your cut is going to play into the accuracy of your plate, because we're going to do numerous things with this plate. We're going to make some marks on it and drill holes. So you got to start with a square plate. So, but again, that would be the easiest way to measure. What I'm going to do, I'm not going to take a measurement. I'm just going to cut a small piece off of there, again, to show you how it operates. So at this point, push my clamp down. Actually, I'm going to pull it out just a little bit. I'm not even going to take that much off of it. I'm just going to do something like that and get rid of those little pieces on there. I just tap that a little bit with my hand, pull down on that, and then because I have the blade so close, I'm going to back it off before starting. I laid these two objects up here. If you wanted to make it out and mark the plate with a scribe or with a piece of soapstone, by all means, that's acceptable also. But I've found over the years, the easiest way is to just measure from the blade and not make any marks to have to try and line up. Kind of like when we cut the 2x4s and stuff. Do you cut the line? Do you leave the line? What do we do with it there? So this is the easiest way. This is pulled back down as low as it goes. Tighten the knob so it doesn't move. Again, I'm going to back it off with this little switch here just to give it time to come up to speed. See how fast it moves backwards. Now I'm going to start my blade, let it start coming up to speed. And here's where I'm going to start adjusting. It's going to be coming pretty quick, so I'm slowing it down. watching. Again, 1/2 inch is pretty thick metal. So we're going to cut fairly slow because there's a lot of metal to cut through this. We listen when it first starts to make sure that it's cutting and we're not going too fast. And I'm going to speed it up just a little bit more. I'm watching and I'm kind of listening. I'm looking for any of the pieces that come off. Trying to see, watching for any heat of the blade. And I would always caution you guys to go a little bit slower with your feet right there and not damage the blade than to go too fast. At that point, I'm going to take this little locking nut. I have it set pretty close to where I want it. I'm going to lock the speed there so it doesn't change. And I'm going to let it continue to cut. Actually, I need to go a little bit faster. I'm sorry I showed you the wrong way. Counterclockwise is going to increase the speed. Clockwise is going to slow it down. Again, I'm watching and listening for any sound. My speed is pretty good there. I'm going to lock it and let it continue to cut. I don't think I'm going to make you guys watch the whole video while it cuts. I think you get the point of how this is working. Last thing I should tell you, here's the air pressure gauge on here. It's set at about 45 pounds. That is the pressure that we're applying with the pneumatic pressure to move the blade, to move the force forward to drive it through there. Everything is regulated off of air pressure. Here again, the carbon steel, 150 feet per minute, 150 feet per minute. We could change that with the up and down arrows there. One last look, we're slowly, steadily cutting through. So I'm going to call that, and you guys know what the result's going to look like. That piece is going to come off. So if you have any questions, let me know.